Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here and this is our fourth video on index form. This time we're going to be talking about multiplying indices and trying to generate a rule for that. So to start with, I've introduced to you index form. How would a mathematician usually write 2 multiplied by 2 multiplied by 2 7 times? Well, they would write 2 to the power of 7, wouldn't they? Now, I'm going to just break up this 2 in different ways. We know that when you're multiplying is associative, so I can do it in any order I want. So let's just say I went like this. I did that on its own, and then I did those multiplied. So 2 here, that's 2 to the power of 1. These 6 2's here are 2 to the power of 6. Obviously, I know my answer is 2 to the 7. What if I did it in a different order? What if I said, right, I'm going to do them 2 and then I'm going to do them 5? 2 squared multiplied by 2 to the power of 5 is of course 2 to the 7. What if I broke it up in a different order again? What if I said, I don't know, like this? And I said, right, 2 to the 4 therefore multiplied by 2 to the 3, well obviously that's 2 to the 7. And I could break it up in any way I want. So let's say I said, I don't know, I did these 2, and then I did these 3, and then I did these 2 last. So that would be 2 squared multiplied by 2 cubed multiplied by 2 squared, and I know the answer is 2 to the 7. Now can you spot what I'm trying to show you? What I'm trying to show you is that when the base number is the same, when you've got powers of 2, what can you do with these indices or these powers? You can add them. 2 to the 1 times 2 to the 6 is 2 to the 7. You can just add 1 at 6. 2 to the 5 times 2 to the 2 is 2 to the 7. 2 to the 4 times 2 to the 3 is 2 to the 7. 2 to the 2 times 2 to the 3 times 2 to the power of 2, I can just add 2, add 3, add 2 and get 2 to the power of 7. Base number is the same and we're multiplying powers with the same base, we can just add the indices. So let's just write that out so we're absolutely sure. When we're multiplying indices, if and only if the base numbers got to be the same, when multiplying numbers in index form, you can add the powers. And I want to give you an example of what I mean for that. So say if someone asked you to simplify or write in one index form, let's say they said, I don't know, 7 cubed multiplied by 7 to the power of 5, you could say, well, that's 7 to the 3 add 5, which is 8. What you're not allowed to do, say if someone said 3 to the power of 5 multiplied by 2 to the power of, I don't know, 8, you're not allowed to add the powers there. You're not allowed to do anything. There's different bases. You're not allowed to combine it. You just have to leave it alone and leave it like that. In fact, what you really should have, you should have it written with the smaller base number first. That would be the mathematical way of writing that. But there's no way you can actually simplify that, let's say. And that's it. That's all you need to know for multiplying indices. The base number's the same, you can add the powers. Let's try some questions. Simplify the following, leaving your answer as an index form. 9 to the power of 5 multiplied by 9 to the power of 3 is going to be 9 to the power of 5 add 3, which is 8. 8 squared multiplied by 8 to the power of 4 is going to be 8 to the 6. 2 to the 4 multiplied by 2. Now this is sometimes where students struggle. That doesn't look like index form. But do you remember the video where we did powers of 0 and 1? That's actually 2 to the power of 1, and it's really handy to be able to do that. So if we add these powers, we clearly get 2 to the 5. 3 to the 4 times 3 to the, that's right, 1 times 3 to the 7. I can add 4, add 1 is 5, add 7 is 12. This will be 3 to the 12, and we're done. Next one, pause and see if you can do. Right, this one, well, we've got different bases on the go here. We've got 5 squareds and 5 cubed, but then at the same time we've got a different base which is 7, and we've got a 7 cubed and 7 to the power of 6. Keep them separate, don't try and combine. 5 squared multiplied by 5 cubed is 5 to the power of 2 plus 3, which is 5. Then we're going to multiply that by 7 cubed multiplied by 7 to the power of 6, which is going to be 7 to the power of 9. Okay, and always write the smaller base number first, and that's it. Don't try and simplify that anymore. That's as simple as you can get. Keep the different base numbers separate. Same thing applies here. 8 squared multiplied by 5 squared multiplied by 8 to the 4 multiplied by 5 to the, that's right, 1. And I'm sure you can see what's going on here. 5 to the 1 times 5 squared is going to be 5 cubed. And 8 squared multiplied by 8 to the 4 is going to be multiplied by 8 to the 6. 2 to the 1 multiplied by 10 to the 1 times 10 to the 4 times 2 to the 1. We can write that as 2 squared multiplied by 10 to the power of 1 plus 4, which is 5. Pause the video and have a think. Colin says that 2 cubed multiplied by 5 to the 6 is 10 to the 9. Is Colin correct? Explain your answer. Well, no, Colin's not correct. You can't add the powers when the base number is different. You're not allowed to do that, okay? So it's definitely not to the power of 9, that's true. Are you allowed to just multiply the two bases? Well, no, you're not allowed to do that. Let me just get the calculator to prove to you that that's not going to work. 2 cubed multiplied by 5 to the power of 6 gets us 125,000. Now clearly 10 to the power of 9 is not 125,000. Let's just show you. 10 to the power of 9 is a massive number there. So you are definitely not allowed to do that. You're only allowed any form of simplification when the base number is the same. If the base number is not the same, keep the things alone. Leave them alone. Leave 2 cubed on its own. Leave 5 to the power of 6 on its own. Don't try and combine either the exponents or the powers or the base numbers. Okay, so leave them alone. On that note, have a think about this. Brian says that 2 cubed multiplied by 5 cubed is 7 cubed. Is he right? Absolutely not. He's not right. Remember I told you when the base numbers are different, right? Don't even go there and try and simplify it and do something crazy like add the base numbers or add the powers or times the base numbers. Keep it separate. It's definitely not right. 7 cubed after all is 343, and trust me, 8 times 125, which would be these two, is not 343, so that's definitely wrong. Okay, have a think about this one. Now Dan says 2 cubed add 5 to the power of 5 is 7 to the power of 8. Is he correct? Well, again, here we're adding, right? So we're not even multiplying, we're adding powers. Now he's trying to do some rule here where he adds the two base numbers and he adds the two powers. I said when the base numbers are different, keep the things totally separate and don't try and combine. So it's definitely not right. To prove it to you, 2 cubes 8, 5 to the power of 5. If I add these together, I certainly don't get 7 to the 8. 2 cubed, right, add 5 to the power of 5. Remember that, 3,133, and 7 to the power of 8 is certainly not that, I promise you. So he's definitely wrong, okay? And the last question. Pause the video and see if you can do these. Simplify the following given your answer in index form. Now when you're multiplying and the base number is the same, this is all good, we're allowed to do this. So this is 9 to the power of 5 add negative 3, alright? Now adding a negative is the same as subtracting. This is just like 9 to the power of 5 take away 3, which is 9 squared. Done. This one here, the base numbers are the same, so you can add the exponents. So this is going to be 8 to the power of 2 add negative 4. Okay, now remember, adding a negative is just like subtracting, so this is 8 to the power of 2 take away 4, and 2 take away 4 by the symmetry of subtraction is 8 to the negative 2. And there you go, that's it for this video, everything on multiplying indices. Thanks for watching.